Now we can actually talk about how we use reference angles for non-acute angles to find their trig function values. Now remember that in section 2.1 we discussed how to find the trig function values for 30, 45, and 60 degrees. These are our acute angles, and we found those function values using our special triangles. We can do something similarly for angles like 240 degrees, something that is non-acute. First, let's start by graphing our angle 240 degrees. We're going to graph this in standard position. And we know that when we go to find our trig function values, we have x, we have y, we have r. We need to know the values for each of those. However, I don't know exactly what point to pick on the terminal side. So we can actually use reference angles and our special triangles to tell us which special point or which point to pick on the terminal side. So first of all, let's find the reference angle. The reference angle for 240, of course we want to know what this angle is here. Well, if this is 240 degrees, the nearest x-axis would be thought of as 180 degrees. So we want to do 240 degrees minus 180, and that gives us 60 degrees. So our reference angle is actually 60 degrees. So what we can actually do is arrange our special triangle to be right here, where 60 degrees is the angle of our triangle that is in that position. So that will be our 60-degree angle there. And we're going to arrange our special triangle to be right there, with 60 degrees being the reference angle. So this would be our 90-degree angle, and of course this would be 30 degrees. So we can arrange our 30, 60, 90 triangle to be in the same little place as our reference angle, and now we actually can tell which point we want to pick on our terminal side. So here's our terminal side there. And we want to know what is the x and y value of the point. And we're going to pick a point that actually ends right there at the very tip of our triangle. So what are our distances associated with our 30, 60, 90? Well, we know the hypotenuse is the longest, and that was 2. So that actually tells me that the r value that I will use will be 2. So let's go ahead and fill that out. So there's my r. And in the x direction, in the x distance, that's across from our 30-degree angle, so that would be 1. So we actually know that our x will be, well, let's think about that again, because if I'm going in the left direction here in the x direction, if I'm living in quadrant 3, then that x would actually be -1. And then my y direction, this side, is across from our 60-degree angle, which would be the square root of 3. So square root of 3, but I'm going down in the y direction, so that would be negative square root of 3. So we can actually use that special triangle lined up with our reference angle to tell us the distances in the x and y direction, and also the distance for r. So we use the point on the terminal side that lines up with our special triangle, and using those distances we can find x and y and r. Now how does that help us with sine? Well, we know that y is negative square root of 3 and r is 2. Cosine is x over r, so it's -1 divided by 2. Tangent, y over x, so that would be negative square root of 3 divided by -1. And of course, two negatives give us a positive. And then, of course, our reciprocals. If I flip this fraction, I will get negative. And let's go ahead and rationalize it. Okay, so if you flip it and rationalize, this is what you get. 240, if I flip that fraction, I get -2. And cotangent of 240, I'm going to flip this fraction and also rationalize. And we get a positive value on this side as well. Now let's look at our values that we actually get. You notice something about these values. All of these values, the numbers themselves, actually are all exactly the same as the trig function values of 60 degrees. So all of the actual numbers themselves are the exact same values as the values of our reference angle 60 degrees. So sine of 60 degrees was positive square root of 3 over 2. But we see the numbers themselves are the same for each of our trig functions. So cosecant of 60 is 2 square root of 3 divided by 3. Cosine of 60 is a positive 1/2. Secant of 60, positive 2. Tangent of 60, square root of 3. Cotangent of 60, square root of 3 divided by 3. So all of our trig function values have the same number as our reference angle 60 degrees. What's the only difference between the values for 240 degrees and the values for 60 degrees is going to be the signs of each of our trig functions. We know that in quadrant 3, the only thing that is positive is tangent and cotangent. And when we go and look through all of our signs, we see that tangent is positive, cotangent is positive, and the other 4 trig functions are negative. So in order to find trig function values of non-acute angles, the first thing that we will do is find the reference angle. Once we have the reference angle, we actually know all the numeric values of all of our trig functions. Then we will use the quadrant to tell us what signs should go in front of those trig functions. Alright, here we're going to do another one, but we're going to kind of streamline the process a little bit. One of the things that we know is that the reference angle for 150 degrees will tell us all of the numeric values of all of our trig functions. So let's find the reference angle first for 150 degrees. So if I graph 150 degrees, my reference angle will be 30 degrees. So here's 150. If I have half a rotation, that would be 180. I'm going to take off the part that I don't want, the 150, and we see that the reference angle will be 30 degrees. Now, if I know what my reference angle is, I can actually use my special triangle. 30, that's going to be 1. Here's our 90, we'll have 2, and here's our 60 degree angle. That's of course the square root of 3. So if I know my reference angle, and I could find sine of 30 degrees, well, sine of 30 degrees would be opposite over hypotenuse, that would be 1/2. Then what is the sine value of 150 degrees? Well, let's first of all look through all of our sines. We are in quadrant 2. So what is positive in quadrant 2? Well, that of course would be sine and cosecant. All of my other trig functions will be negative. So I can already determine all of the signs of my trig functions. And now I will just look at the sine of 30 degrees would be 1/2. So it tells me the sine of 150 degrees would have the same numeric answer. So it would also be 1/2. What is the cosine of 150 degrees? Well, the cosine of 150 will be the same as the cosine of 30 degrees, since this is my reference angle. So that would be adjacent over hypotenuse. So that would be square root of 3 divided by 2. Tangent of 150 would be opposite over adjacent, so that would be 1 divided by the square root of 3, which we know would be square root of 3 divided by 3 when we rationalize. Now I can do with my reciprocals. The reciprocal of 1/2 is 2. The reciprocal of negative square root of 3 divided by 2 would be 2 divided by the square root of 3. And of course we want to rationalize. and the reciprocal of 1 divided by the square root of 3 would just be the square root of 3 over 1, or just the square root of 3. So we can use our reference angle to tell us the numeric values of all of our trig functions, and based upon the quadrant, that'll tell me the sines of all of my trig functions. Find the values of the 6 trig functions for 315 degrees. The first thing we want to do is graph 315 degrees. Two things that we want to know. We want to know what quadrant that we're in, and we can tell that we are in quadrant 4. And remember that the reason why I want to know the quadrant is I want to know the sines of all of my trig functions. So, what functions are positive in quadrant 4? Well, that would be cosine and secant. Everything else will be negative, so I can already put my sines in. And the next thing I would like to know is the reference angle. We know that the reference angle will tell us the numeric values that go behind the sines of all of my trig functions. So 315 degrees, between its terminal side and the nearest x-axis, which we can think of as 360, that would be 360 degrees minus 315 degrees. That tells me that my reference angle is 45 degrees. So let's think of our special triangle for 45 degrees. So my special triangle would look something like this. Here's my 90-degree angle. Here's my 45, 45. The hypotenuse is square root of 2, and the sides are both 1. And we're working from the perspective of our reference angle 45 degrees. And we know that this would be the opposite side. This is my hypotenuse, and this would be the adjacent side. So sine would be opposite over hypotenuse. So that would be 1 divided by the square root of 2, which we know that when we rationalize, we get square root of 2 divided by 2. Cosine is adjacent over hypotenuse, 1 divided by square root of 2. So this time we get positive square root of 2 divided by 2 for cosine. For tangent, that would be opposite over adjacent, so it would be 1 divided by 1, which is just 1. Cosecant would be the reciprocal, so that would be just square root of 2, so the reciprocal of sine just be the square root of 2, and it's negative square root of 2. Secant, reciprocal of cosine, so once again that would be just square root of 2 divided by 1, which is just square root of 2, so we get positive square root of 2 for secant. And for cotangent, the reciprocal of minus 1 is also minus 1. So once we know sine, cosine, and tangent, we can use our reciprocal relationships to find the last three. It all goes back to what quadrant that we're in. That tells us our sines. What's our reference angle? That tells us all the numeric values of each of the trig functions. Find the values of the 6 trig functions for 420 degrees. First, let's graph our angle 420 degrees. We notice that 420 degrees is larger than 360, so let's find how many rotations need to be completed. So we have 360 minus 420, we get 60 degrees. So we have one complete rotation and then 60 degrees more. We can tell that since we went one complete rotation 60 degrees more, without any calculations to determine my reference angle, we can just tell that it's 60 degrees. So we know that our reference angle is 60 degrees, and we also know that we are in quadrant 1, which tells me that all of my trig functions should be positive. So we want to use our 30, 60, 90. we need to know the sides of each. My hypotenuse is 2. Across from the 30 I have 1. Across from the 60 we have the square root of 3. Remember that we're working from the perspective of our 60-degree angle. So this would be the opposite side. This is my hypotenuse, and 1 would be my adjacent side. So sine of 420 degrees will be positive, and it will be opposite, so that will be square root of 3 divided by the hypotenuse, which is 2. Cosine will be adjacent over a hypotenuse, which will be 1/2. Tangent is opposite over adjacent, so I get square root of 3. And then we can use our reciprocal relationships. When I flip sine, we get 2 divided by the square root of 3, which when we rationalize, we get 2 square root of 3 divided by 3. Secant is the reciprocal of cosine, so I get 2. Cotangent, the reciprocal of tangent, so that will be square root of 3 flipped, so that would be 1 divided by the square root of 3, and when I rationalize, square root of 3 divided by 2. So it's as easy as knowing what quadrant you're in to tell you the signs, and knowing the reference angle. We can work from the perspective of that reference angle in our special triangle to tell us the numeric values for each of those trig functions.